All right, so here are a couple more. So number 5, here we have a cube root, an odd index, right? And a negative. So all that means is just that negative is going to come out, right? So since it's odd, it's just going to come out as a negative, not as an I. So it's just going to be a negative. And then the cube root of 27, I know that 3 cubed is 27, so 3 comes out, right? Or I could do a factor tree. Now a to the 6 is a little different. So if we break down a to the 6, and you don't have to show this work every time, but it might be good just to show it one time. So a to the 6 is a product of 6 a's, right? So what I have here is I have 2 sets of 3, right? And so that means I'm going to have a times a on the outside, which is a squared. So essentially what you can do is take the inside exponent and divide it by the index. So that's essentially what we do when we bring out variable expressions with exponents. Or, my bad, 6 divided by 3, sorry. Okay, because we're saying how many groups of 3 go into 6, right? And so that's a division problem. So anyway, so you can think of it, this way if you want, or this way if you want. It's up to you. All right, so here we have a 4th root of 16w to the 4th v to the 8th. Okay, so the 4th root of 16 is 2, right? I know that with my common powers list, or I could break down 16 and I get 4 2's. And then w to the 4th, 4 divided by 4 is 1, right? So that's one group of 4. So I have w to the 1st, but w to the 1st is just w. And then v, and then 8 divided by 4 is 2. So I have 2 groups of 4 there. So 2 v's can come out. All right, so that's it right here. Oh, and I forgot to mention one thing. So when we're dealing with variables, remember that those could be any value. They could be positive or negative. Now, when we square anything, when we square a real number, we get a positive, and so it's okay to have this come out. But when you have any variable that comes out to an odd power that could return negative, you have to put absolute values around that. Okay, so it's 2 absolute value of w v squared technically, right? If we want the principal root to come out, then we don't want the negative value of w, we want the positive value of w, right? Because if we simplify in here first and we do negative w, if w is negative and we put it to the 4th power, it'll turn positive, and then we'll get the positive value of w to come out with the 2 and the v squared. Okay, so keep that in mind. So when you have even indices and an odd exponent, a variable with the odd exponent comes out, then you apply absolute values to that variable, okay? That variable expression. All right, number 7. So here I have a plus b squared. Now I can't really simplify a plus b because those are not like terms. So I'm just going to let these cancel out. And so I'm going to get a plus b, but just like we talked about, a plus b, those could be positive or negative. They could be any combination of those. So I just want to make sure that my answer is the principal root there. So I'm going to put absolute value of a plus b. All right, and that'll be my answer. All right, and then finally, number 8, I'm going to let you do that one on your own. Okay, so try that out. All right, so if you got 9c squared, good job. So do what's inside first. So negative 3 to the 4th power is positive 81. And then we get c to the 4th. And we take the square root of 81, we get 9. Square root of c to the 4th is c squared. Since it's even exponent, it's going to come out positive as long as c is a real number. And so I don't have to worry about the absolute value.